Great. So the first thing we're going to look at under coordinate geometry is equation of a straight line. Now, equation of a straight line is given in item 1 here. It's y equal to mx plus c. So if we look across here, we'll see what that is about, right? X and y in this equation here are representing the coordinates on the line, points on the line. So every point on a line would have an x coordinate and a y coordinate, right? In order to plot it on the line, it must have an x and a y coordinate. So this x and this y would be the coordinates of any point on a particular line, right? C is the y-intercept. This C here is the y-intercept. What is the y-intercept? The y-intercept is the point where the line cuts the y-axis, right? And the coordinates of the y-intercept will always be 0 for the x and c for the y, right? So this c here is really that y coordinate. For sure, they say it's the y-intercept, right? And you need to be wary of that, okay? So if I just draw something quickly here for you, I'll draw it. I'm just gonna draw it right here, right? I'm drawing a y-axis and a x-axis, right? If I draw this line here like this, right? That line is going to intersect the y-axis at this point here that I'm circling. And that value there will be the C, which is this C here, right? And the coordinates of that point though will be 0, C, meaning you don't need to move anywhere in the x direction, left or right, you just need to go up to get to that point, okay? So that's what the C is about. Then the next very important component in this equation here is the M value, right? The M value. What is the M value? M is the gradient of the line. And what does gradient tell us, right? Gradient tells us the slope or steepness of the line, right? So the steeper a line is, the greater the gradient of the line, okay? Or the steeper or the greater the slope, then the greater the value of M is. So if I have this line here, right, its gradient might be, let's say 1. If I draw another line like this, its gradient will be more than 1. It might be 2, right? And so you notice how it's sloping, right? If I draw, of course, here's the y-axis and here's the x-axis. If I draw another y and another x, right? And I draw a line going this way, right? That gradient is going to be negative because of how it is sloping. So any line that is sloping, as in these here, those will be positive. Any line sloping like in this one here, that one will be negative, okay? And of course, the greater the steepness or the slope, the greater the M value, which is this value here, right? So we say M is the gradient of the line, and it tells us the slope or steepness of the line. Now, there's another way to come up with M. It's the vertical rise divided by the horizontal run between any 2 points on a line, right? And that could be found by saying y2 minus y1 over x2 minus x1, right? We're gonna see what are these values here, right? And basically they refer to the coordinates of 2 points on a line. So once you have 2 points on a line, you could always find the gradient of that line or the slope of the line or the steepness of the line, okay? And that's this second equation here, which says that M in this equation, which is the gradient, is the y coordinate of a second point, take away the y coordinate of a first point over the x coordinate of a second point minus the x coordinate of the first point. This here really gives us the vertical rise between 2 points. This here gives us the horizontal run between any 2 points, right? But these are the 2 main equations you need to be focused on when you are working coordinate geometry, equation of a straight line. So if we come down here, the types of questions that you could get in your exam, and we are focused on multiple choice. But any question you have more or less in a paper 2 long paper, which you are not scheduled to get now, could be adapted to go into a multiple choice. So that's why it's still important to cover the topics, right? And also in paper 3-2, the syllabus for paper 3-2 is the exact same syllabus for paper 2. So those of you who have to do paper 3-2, you all have to also know the syllabus, the entire syllabus. So that's why we still need to go it over. All right, so that's why we are doing this now. So the general types of questions you could get under coordinate geometry and more specifically the equation of a straight line would be this first type where you're given the gradient of the line and the coordinates of a point on the line. And they ask you to find the equation of that particular line, okay? So let's look at an example of where you are given the gradient of the line and the coordinates of one point on the line. So in this example, you're given that the point -3, 5 lies on a line with gradient -4. In other words, the line has a gradient of -4. Find the equation of the line that we are talking about here, okay? Now you see this -3 and this 5. This is a x value here and this is a y value, okay? So x could be considered to be -3, right? That's this x, and y could be considered to be 5. All right, so that's very important for you to be aware of. So this is a x value, this is a y value. Now, the gradient is the first thing that we're going to try to find, because remember, y equal to mx plus c. If they don't give us the gradient, then we have to find it. Now, if you notice here, they said the gradient of the line is -4. So that means we have this m value already. That's -4. Good? So we could actually write down m equal to -4 right there. So that's important. We have that. And this value here that we get, we're going to put it into the equation of the straight line, y equal to mx plus c there, right? So we always need to get this value. And we always also need to get the c value here. Good? We are given a x and a y value already, x and a y value already. Look them here. We were given x as -3 and y as 5. So we're going to substitute in y equal to mx plus c those two values. X as -3, right? X as -3 and y as 5. So let's do that. This y as 5 is going to go right here. So I'm going to put it in. Y is going to be 5. Let's change that back to black ink, right? So y is going to be 5 equal to the m value we said we had put in as -4, right? The x value, let me put a bracket and put x in there. The x value we said is -3, get here. So I'm going to put that -3 right inside of there. And then if you notice, the only thing that is missing to figure out to get the equation of this line is the value for c right here. We still have to work out that. So let's put in our value c because it's unknown. Okay? So that's very, very important what we're doing. So if you notice, the only thing that is missing here is c, so we just have to solve for that. So let's solve for that. 5 is equal to -4 by -3 is 12, right? Plus c. So the only thing we have to do now is solve for c. So 5 take away 12 must be equal to c. We minus 12 on both sides, or some people say bring the 12 on the other side and change the sign. So now we're gonna be able to work out what c is, and 5 take away 12 is equal to -7. Okay, so have we solved the equation? The answer is yes, because we now have the value for c. This value here is important. So we just got it. C is equal to -7. Right? I think I saw somebody asking something. Let me just see.
So ignore that message.
Huh?
Ignore that message.
Good to see you. Oh, you were messaging.
I could have done it differently, but
Okay.
I just realized I
Uh,
can only message you privately.
all right. Okay. No problem. Right. So it wasn't me ignoring somebody. Right. So what we are saying now is that we have our C value. So we could write the equation of the line. Now we could say, seeing that the equation of a line is y equal to mx plus c. And if you recall, the main things when we're doing that is to find the value of m and to find the value of c, right? Which we have done. We could now write the equation of the line as y equal to m, which was given to us as minus 4, times x plus c, and c is minus 7. So it'd be plus minus 7 or simply minus 7. And this is the answer that they wanted, right? They wanted to know what was the equation of the line. So this here is the answer that they wanted. Okay, so this is the first type, right? Let's recap. This is the first type where you're given the gradient of the line, which was minus 4 in this here, gradient of minus 4, and the coordinates of 1 point. The coordinates they gave us was minus 3, 5. This is a x value, that's a y value, right? So we substitute x here as minus 3. We substitute y here as 5. We substitute the gradient they give us here minus 4. We substitute that for m. So the only thing that was missing was c. We solve for c. And once we solve for c, now we could write the equation of the straight line, which is always y equal to m, which they give us, times x, plus c, which we solve for here. Okay? Right? So you could go and do some practice with that. What is the second type? And these are the general types that you get, right? The second type, or type 2, is where we are given 2 points on a line. So the example in this case might be, what is the equation of a line, or the line, which would pass through the points 4, minus 3, and minus 2, 5? Okay? So they want you to work out what is the equation of this particular line that's going to go through these 2 points. All right? So what we will do is call one pair of points, let's say this one here, let's call that x1, y1, x1, y1, okay? And let's call the second pair of points x2, y2, okay? So now you have named these points, right? In terms of x1, y1, x2, y2. You could call this one x2, y2 and this one x1, y1 if you wanted. It doesn't matter, right? But I choose to call it x1, y1, x2, y2. Now, if you observe in the last question, they gave us the gradient. See, the gradient was minus 4. In this question, they did not give us the gradient. But as you know, to write the equation of a line, you must have the gradient. If they didn't tell you, it means you have to work it out. So let's go to finding our gradient first. Our equation is gradient m is y2 minus y1 over x2 minus x1. Now remember, when you're learning it, don't mix up the order, right? Don't write y1 minus y2 over x2 minus x1. No, the order is very, very important. It must be y2 minus y1 over x2 minus x1. So let's go with that. Y2, in this case, let's look across here. Y2, look, Y2 here would be 5. So I'm going to write down 5. Minus Y1. What is Y1? Look, Y1 here. Let's go across here. Y1 is going to be negative 3. Now, here's the trick. Sometimes people just write down 3 here, but it's really negative 3 after write down. Now, instead, let's not get confused. Let's put a bracket around it so we wouldn't get too confused with the other negative that was there. Okay, over x2 minus x1. What's x2? X2 here is negative 2. So we're going to write down negative 2, right? Minus, see this minus sign? I'm going to put it here now. Minus, and what are we going to minus? X1. X1 in this case is 4. Okay? So let's review that, because putting down the correct numbers with the correct signs is so important. Otherwise, you're going to end up with errors. Okay? So y2, 5, look, I put the 5 here, minus, look, this minus here, y1, y1 is -3. So I put the -3 in there, right? Over x2. What is x2? -2. We put the -2 in. Minus, look the minus here. And then x1. x1 is 4. Okay? So be very careful. Take your time and do it, right? So you'll get the right answer when you work it out. Okay, so let's work that out now. 5 minus minus 3. That's this top part here. Minus minus is a plus. So that'll become 5 plus 3 on top. And below, it'll be minus 2 minus 4. Minus 2 minus 4 is minus 6. So you're going to get 8 over minus 6. Right? And 8 over minus 6 is the same thing as a negative, right? Because when you divide a positive 8 by a negative 6, the result, the answer you're going to get is going to be a negative result. Because if you divide a positive number by a negative, because the signs are unlike, the result is going to be negative. So your final answer is going to be a negative answer, right? Now, 8 over 6 is the same thing as 4 over 3. So that could be written down as -4 over 3. So what we worked out there is the gradient of this line, and it's working out to be -4 over 3. Again, you have to be very, very careful. Good? So our first step, just as in the one before, if they don't give us the gradient, we would look for it, and if it's there, we use it. If they don't give us, we have to work it out. So now we know what our gradient is. Our gradient M has worked out to be -4 over 3. So keep that in your mind, right? And now that we have the gradient, we're gonna use the same process from here that we would have used in the question before, which is we're gonna choose one of the points, either this point here or this one, right? And use that in the equation y equal to mx plus c. That is, use it in this equation, right? So let's see. I am choosing out of these two, I'm going to use -2, 5, right? As this one as x and this one as y. So if you notice, I wrote it here. Use -2, 5 as xy in y equal to mx plus c. So let's write it down. Y equal to mx plus c. We said we are going to use this one as x, this one as y. 5 is therefore going to be y. So 5 is going to come here. So I'm going to write down the 5. What am I going to use for m? Well, look, m here, calculated, worked out to be -4 over 3. So where I see m, I'm going to put that number in. Let's write it in, -4 over 3. Plus c. Well, just like the one we did earlier, c was the thing that was missing after we put in all the things that we knew. So that means we have to solve for c. All right, well, if 5 is equal to -4 over 3 plus c, then 5 plus 4 over 3 must be equal to c. How do I do that? Well, I add 4 over 3 on the right, which would cancel this out, but I must also add the same thing on the left. So that's why you see this here on the left, and this is missing from the right. Another person might tell you, take this -4 over 3, bring it over on the next side, and change the sign to a positive. Okay? That's a shortcut method, but it's sometimes easier to grasp, right, than what the real thing is, what I said earlier. In any case, this is the process here. And when you take 5 and you add 4 over 3 to it, right, you're going to get 7 over 3. Yes, now, did I make a mistake here? Yes, I am making a mistake here because I didn't put in the x value. So I couldn't do this as yet. Please forgive me. All right, so let's just go back a little bit. Notice I had put in the y value as 5, the m value is -4 over 3, but I didn't put the value for x in as yet. So that was an error on my part, so I'll correct it now. Right, remember we had said the -2 would have been the x value. So I have to put that -2 where the x is right here. Okay, so let me put that in, sorry about that. And then the plus c. So I omitted to do that, so I am correcting it now. So 5 is going to come here, right? Negative. This outside the bracket means multiply by a negative. The answer is going to be a positive answer. And 4 over 3 multiplied by 2 is going to be 8 over 3. It's positive 8 over 3 because we multiply numbers with the same sign, two negative numbers. So the answer is positive, 8/3, right? And now we have the plus C, right? So what you realize there is that C is the missing and only unknown factor in there, or entity. So we're going to work out C by simply saying 5 take away 8/3 is going to give us C, right? Bring this over on the other side and change the sign, or minus 8/3 on both sides, and you're going to get your value for C. Okay, so if you put that on your calculator and you work it out, you're going to get a value for C as 7/3, right? 7/3. So we're going to get 7/3 for C. So let's just take a note of that. C is 7/3. Why is that important? Because now, since y equal to mx plus c is the equation that we need to end up with, right? We could write the equation of the line now as y equal to m. What was m again? Well, look at here. M was -4/3, so we're going to put it there. -4/3, because you always have to fit in what m is. X, let's put the x, plus c. What is c? We just worked out c. C is 7/3. 7 plus 7/3. So now we have the equation of the line that they wanted, which is y is equal to -4/3x plus 7/3. Now we could do some more things if we want. The -4/3, that's an improper fraction. We could make it into a mixed number. So we could write it as y is equal to -1⅓, right? Plus 7/3, because -4/3 is the same thing as -1⅓. Okay, and then sometimes they even want in your exam, they might even tell you, they might even give you this as an option, right? They might give you this as an option that I'm going to tell you, and then you would have to be able to recognize that this and what I'm going to write down here, 3y is equal to -4x, right, plus 7 are representing the same line. So in your multiple choice, they could give you the same thing to work out. You work it out, and they give you A, B, C, and D. But when you look among A, B, C, and D, you do not see this, nor do you see this. So you will say, oh my God, maybe I did something wrong. But there's another step that you can do, and they could present an answer having used that step. What is that step? That step is a step to remove the denominators. When you have fractional terms, like here, how these terms are over 3, right? They have the denominator of 3. You could get rid of this by simply looking at and noticing this and multiplying this whole thing by 3. So if we multiply, right, throughout by 3, let's see what would happen, right? I'm going to multiply this throughout by 3. So I'm multiplying the left-hand side by 3. 3 times y is 3y. I'm multiplying -4/3 by 3. I'm going to get -4. The 3's will cancel, x. And then I'm going to multiply the 7/3 by 3. That means the 3 at the bottom will cancel out, and I'll just get 7. So if in your exam they had presented you with this as option B, right, and nothing else was like what we had here. In other words, you didn't have this on as an option, you didn't have that one as an option, but you had this as an option, then you would have to know how to move from here to here and give them this as the correct answer. Okay, and how do you do it? You look to see what is the denominator, right? Find the lowest common multiple and multiply throughout by it. So to eliminate this, right? All right, so that is how you would do questions of type 2. I've seen questions sometimes where they give you C, which is the y-intercept, up front. Notice in these, both of these, you had to find C, right? And here you had to find C in both of type 1 and type 2. Sometimes, very infrequently, maybe 1 or 2% of the times, they structure a question where they may give you C up front. That is the y-intercept up front. Here, you do not have to find it. It will be given to you already. You just have to observe and make sure you recognize that they give you the y-intercept, right? And you simply use it to state the equation of the line because you won't have to find it. It would be given to you already. So they might give you the gradient and they might give you C in a, in a very underhanded way. You have to recognize, well, okay, this is the y-intercept, and therefore you use it. Okay, let me give you an example of how they could give you in an underhanded way. They could tell you the line goes through the point 0, 4. But anytime they give you a point that the line goes through where the x-coordinate, that is the x-coordinate there, is 0, then this here is the y-intercept. Okay? So they didn't tell you it was the y-intercept, all they tell you is the line passes through the point 0, 4. But you have to know that once the x-coordinate is 0 for a point through which the line passes, then that point is the y-intercept. So all you have to do now is say, right, the y-intercept is 4, whatever gradient they give you. Let's say the gradient is 2, then you just simply write y equal to 2x plus 4 is the equation of the line, okay? So these little things are the ones that you will find when you do many past papers, because remember, in 10 past papers, you mightn't see one like this. In the 11 past paper, you might see one like this because it is not a frequent type question, but it could come in the exam. So just be aware of that, okay? And there might be one or two other types that you will only pick up when you do multiple, right, past papers. Any questions on this? Anybody want to ask anything before I move to the next stage?
No, sir.
Right. All right. So the good thing is that this is recorded. So when I put it up on YouTube channel, you can always go back and review it. Okay. Have no fear. Again, if you all are doing questions and you bounce up any question, just take a picture of it, WhatsApp it to me, and I'll work on it and send you back a response. Okay. All right. So what is the next thing we're going to look at? We're going to look at some other important properties of straight lines, right? So we basically looked at straight lines and how to find the equation of a straight line. And they may even ask you simply, what is the value of m, what is the value of c? Or what is the gradient, what is the y-intercept, without asking you to find the equation of the line, right? So they could ask you just to find m and c, or they could ask you to find the equation of the line where you have to take m and c and put it into that form that we just looked at, which is the y equal to mx plus c form. Now, what are some other important properties of straight lines you guys need to be aware of? Well, the first one that I want to highlight is this one. If two lines are parallel, then their gradients are equal. Okay? If two lines are parallel, their gradients are equal. Now, y equal to mx plus c, right? So if two lines are parallel, then this value here must be the same. Those values there must be the same. So I would like you guys, okay, to look at it for a brief moment, and I will give you maybe about 3 minutes, right? I'll step away a bit and come back. I'm just going to get some water. But you look at that and you pick out for me. Tell me, is line 1 and 2 equal? Parallel? Is lines 1 and 3 parallel? Is lines 3 and 4 parallel? You tell me which pairs of lines are parallel based on the fact that if two lines are parallel, their gradients must be equal. Right? I'm going to give you a couple of minutes to work on that for me, and I'm coming right back to work on that.
Ian? Is it muted?
Okay, you guys. So let me hear what you all have for me. State which lines are parallel. Anybody? Go ahead.
So 1 and 5?
1 and 5. Okay, so I'm writing down that 1 and 5. Okay, and I think that's Renner, right? 1 and 5. Okay, anybody else had any other ideas besides 1 and 5?
No, sir.
No. All right. So that I recognize McKessie. McKessie, you agree with 1 and 5?
Yes, sir.
You agree with that? All right. Okay, so nobody else has any ideas there? All right, so I'm not hearing anybody else. So Rena, 1 and 5 is correct, right? But you didn't recognize this one, neither did McKessie. What about 1 and 4? What about 1 and 4, you guys? Why is that not correct? Right? 1 and 4 is also correct. In fact, 1 and 4, let's look at equation 4, right? I'm going to write over equation 4 as y is equal to 3x plus 6. So all I did was bring the 3x up in front and put the 6 after it, because remember, if you say 6 plus 3x is the same thing as 3x plus 6,
Yeah.
right?
Yes, sir.
Yeah, so you notice that and I'm going to write back y equal to 3x plus 4 on top. So are you seeing, of course, that the 3's are the same?
Yeah.
Yeah? So, Mackenzie, you see that now?
Yes, sir.
Right. So 1 and 4 will be parallel because the value in front of x, which is the m value, right, would be the same. But some people may not understand why 1 and 5 is the same. So let's write back 1 again here. Y is equal to 3x plus 4. And let's come and look at 5 here now. 5 is 2y is equal to 6x plus 12. And somebody might say, but how they could say that? Because in the first one, the value in front of x, which is m, is 3. And in the second one, the value in front of x is 6. So they are not the same numbers. But remember, for those who are not clear on that, if you look on the left-hand side here, this is not y, this is 2y. So that means you would have to get rid of this 2 to put it in the form that we need to look at. So to get rid of this 2, it means I have to divide by 2. So if I divide this by 2, right, 2 into 2y, I'll get y here. But remember, whatever I do on the left, I have to also do it on the right to keep the equation balanced, right? To keep the equation valid. So if I divide this side by 2, to put it in the form y equal to mx plus c, that means I have to divide this by 2. So 2 into 6x will be 3x. And I also have to divide the 12 by 2. 2 into 12, 6. So now what you would realize now is that the number in front of the x here is now 3, and it is in the form y equal to mx plus c. So let me write it right here. Y is equal to 3x plus 6. So that's y is equal to mx plus c. If you notice the 3 is there again when it is in that form, y equal to mx plus c. Okay, so that's about it for recognizing when lines are parallel and their gradients are equal. Okay, the tricks here is that one, they could switch around everything here, and therefore you have to recognize that this could come up front, or they could have a multiple. Like here, this is everything is multiplied by 2, right? And that's why 2 times 3x here would have given us 6x. So to get it into the form, we'd have to divide it. It could have been multiplied by 3 as well. 4, right? And then everything here would be multiples of 4. So you'd have to divide by 4 and so on. So you just look to see what is in front of the y, divide it through, and when you get it to that form, if the number in front of the x, like here, is the same as any other one, then those two lines would be parallel. The next thing I want you to be aware of, another property you need to be familiar with, is if two lines are perpendicular, the product of their gradients is -1. Okay? Now, let's see what that means. Or if one line gradient is m, the other line's gradient is -1 over m, right? If these things occur, then we say that the lines are perpendicular. So you guys quickly look at 1 to 4. And could anybody tell me if any pair of these lines are perpendicular?
3.
Say it again.
2 and 3.
2 and 3. Okay, so 2 and 3. Right, yes, that is looking pretty good. 2 and 3. Why not 1 and 3?
1 and 4.
And 1 and, right, 1 and 4. Somebody said 1 and 4. Who said 1 and 4?
I did. Right now.
Rena. Right, so there's more than one pair of perpendicular lines that are perpendicular to each other, right? So let's see. So Rena said 1 and 4. So let's look at 1 and 4. Lines 1 and 4. If you look at line 1, its gradient is 2. So let's write down m and m1, right? Meaning, or let's write down m and m1s. M would be the gradient of one line, m1 would be the gradient of another line. So if we are investigating lines 1 and 4, the gradient of line 1 is 2. So let's go and write down m as 2, right? And let's look at the gradient of 4, right? Y equal to mx plus c, that's -1/2, -1/2. So that'd be the gradient of 4. So if these lines are parallel, when we multiply them, we're going to get minus 1 if they are parallel. So if we multiply 2 by negative a half, on your calculator, you're going to get minus 1. That means that the lines that these two gradients came from, 1 and 4, are perpendicular. Why? Because when you multiply their gradients, you get negative 1 as the answer. Rena also said, which one was it? 2 and
3.
3. So let's check out 2 and 3. The gradient of line 2, right, was negative 2. So let's write down that. Right, the gradient of line 3 is not this. It'll be the number in front of the x when you have y equal to mx, right? And this would be c here. So the gradient there will be the number in front of x, which is a half. So let's write down a half. And now if we multiply them, let's see what the answer is. Put it on your calculator, negative 2 by a half. You should get negative 1. So that is correct. What we have learned is that in both cases, the test that we do, which is to multiply their gradients, if we get negative 1, as stated here, right, then we are sure that the lines are perpendicular. So lines 1 and 4 and lines 2 and 3 are lines that are perpendicular. Also, if you take line, let's just do it for this option here. If you take the gradient from line 1, which is 2, right? Right, and we put 1 over it. So we put 1 over m, 1 over 2, and you multiply by minus 1, right? Then that should be the gradient of the other line that is perpendicular to. And look, that's the case here. So if we take 2, invert it, put 1 over it, and then multiply by minus 1 like stated here, we get this answer, which is the gradient of line 4. So that's another way you can test to see if two lines are perpendicular. So if one line gradient is m, the other line gradient is minus 1 over m. If one line gradient is 2, the other line's gradient is minus 1 over 2. So that's also a test you could have performed, right? So that was good, Rena. You see, these two would be the perpendicular lines. Now, there are two other properties you need to be aware of. The first one is these two, I think, are normally given at the front of the paper, but as in paper 2. So if you are given this and you don't know the formulae, you may be in a spot of problems. So here are the formulas you need to know. If you want to find the length of a line that joins 2 points whose coordinates are given, this is the formula here. What is it? Square root of x2 minus x1 squared plus y2 minus y1 squared. That will give us the length of that line. What about if you want to find the midpoint of the line that joins 2 points whose coordinates are given? Well, the x coordinate will be x1 plus x2 over 2, and the y coordinate will be y1 plus y2 over 2. All right? So let's do an example so you can see what this is about. Find the length and midpoint of the line that joins the points 2, 4, and 6, 10. Okay? So we're going to do that one now. First thing we have to do when you have 2 points like this is to name them. So we call this one x1, this and y1. So A is x1, y1. And B, well, I didn't put B, so let me call this B, right? This here is going to be x2, and this here is going to be y2, okay? So now we're going to apply this formula here, this one. So to find the length, we're interested in finding the length. That length, we could call it the length AB, right? We're going to use the formula square root of x2. What is x2 in this case? x2 is 6, so we're going to write down 6. All right, that's x2 minus x1. So we're going to minus, what is x1? x1 is 2. So we minus 2. Squared. See the square there? Squared. Plus what? y2. What is y2? y2 is 10. All right. All right. Minus y1. What is y1? Let's look for y1. y1 is 4. All right. squared. So we're going to square it. Good. So that's how you're going to get the length of the line that joins A and B together, right? That line segment, we call it the line segment AB, and this is how you work it out. So that is going to be the square root, right? We still put back our square root sign. 6 take away 2 is 4 squared, plus 10 take away 4 is 6 squared, okay? So that's going to give us the square root of 16 plus 36. 16 plus 36 is 52, right? And the square root of 52 will finally give us the length of AB. Now, the square root on your calculator for 52 is going to be 7.2 something. So we're going to write down 7.2 when you round it off to one decimal place. And it's going to be whatever units, right? So it'll be 7.2 units will be the length of the line segment AB. Now, square root takes two values, plus or minus. But in this case, it's the length of something. So it's going to remain as 7.2 plus 7.2 units. All right, so that's how you use that formula, this one, and you need to be aware of that. And then the midpoint, we're going to find the midpoint. So find the length and midpoint. So we're on to the second part, which is the midpoint of the line that joins the 2 points. So how do we go about finding the midpoint? Well, let's call the midpoint M, right? That midpoint M, right, is going to be made up of a X value and a Y value. Okay, the midpoint X value is normally called X bar, and the Y value or Y coordinate of the midpoint is normally called X bar. Okay, and what is the formula? Well, you could go back and look at the formula here. It's X1 plus X2 over 2 for the X coordinate, right? X1 is 2, X2 is 6. So if we're going to use X1 plus X2, that'll be 2 plus 6 over 2. Let's look at it here. X1 plus X2 over 2. X1 is 2, X2 is 6. So it'll be 2 plus 6 over 2, which is what we have here. And for the Y coordinate, we have to do the same thing. What is it? Y1 plus Y2 over 2. Another way of saying it, it's the average of the Y coordinates. Okay, so that'll be 4 plus 10 over 2. That'll come here. 4 plus 10 over 2. So our midpoint M is going to have coordinates 2 plus 6 on top, that's 8 over 2, which is 4. And 4 plus 10 on top is 14 over 2, is 7. So our midpoint is going to have coordinates 4, 7. All right, so those are the extra properties and how we apply the formulas to get the various items. All right, so you should look out for these, look for practice, so you'll be able to utilize that as you see fit. Any questions at this point?
No, sir.
All right, anybody, any questions? All right, so that would be some coordinate geometry, all right? The next thing we're going to look at is sketching of quadratic curves, right? I'm not sure exactly how and where this would come in your situation, right? But it could come. It all depends on what they, what part they want to bring in multiple choice or in paper 3. All right, so I'm going to go through it. It requires you to know something called completing the square, all right, which is sometimes really challenging for persons, but I'll go through it thoroughly here for you, right? So the curves that we're going to look at sketching would be curves that are made up of quadratics, or have the quadratic format. What's the quadratic format? Y equal to ax squared plus bx plus c. which is, for example, y equal to 5x squared plus 2x minus 7. Here, a would be 5, b would be 2, and c would be minus 7. That's an example of a quadratic curve. So our particular example would really be looking at a past paper question where they did extensive work on this particular quadratic equation, and you had to end up sketching this, right? So there are some important points that you need to note, right? Anytime you're dealing with quadratics and quadratic curves, and then completing the square, all right? So let's look at a few of them. The first point I want to remind you of is this. We could always know if the curve that we have to draw for this quadratic is a hill or a crest. That is to say, the quadratic has a maximum point, or if it's a trough, right? A trough means you go down into a valley. And in that case, the quadratic would have a minimum point. And we would always know this by looking at the value of a. What is a? A is this number here in front of the x squared term. Now, if a, when we look at it, is negative, it means the curve is a hill or a crest. And it would look something like this, up and down, have a maximum point right there. Now, if a is positive, the curve is a trough. That means it will go down and come up like this, meaning it has a minimum point, right? So this is the first point you need to be aware of. So if I'm looking at this, which is the one we finally going to be looking at an example on from the past papers, right? This number here would tell us if it's a hill or a trough, right? If it has a maximum point or if it has a minimum point. Which one would it be in this case for this equation? If we're sketching this, would it be one that has a crest or a trough? Anybody?
A hill.
It'll be a hill.
Yeah, positive.
You're right. It'll be a hill. It'll be a hill?
No, it's not a trough. Sorry.
No, it won't be a hill. It'll
It'll
be
be
a
a
trough.
trough.
It'll be a trough,
Sorry.
right? Why would it be a trough? Because if you look at the value of
Because
A,
the coefficient of x is positive.
it's positive, right? So if A is positive like this, it's going to be a trough. So right away we know the general shape of this graph if we had to plot it. Point 2, the value of C will always give us the y-intercept. What C we talking about? Well, look right here. Y is equal to ax squared plus bx plus c is the general form. In this particular case, y is equal to 5x squared plus 2x minus 7, right? If you look, this is the C value here, it's minus 7. So this is where this curve is going to cut the y-axis. That is known as the y-intercept. Good? Point 3. So you learned 2 points already. What's the first point? The value of A tells us if it's a hill or a trough, sorry. And the value of the y-intercept is given by C, which is this last number here in the equation of the curve, right? Or the quadratic equation. The third point, if we solve this equation for x, the answers we get are the x-intercept. So that's the third thing you're learning tonight if you didn't know before revising. Solving mean, okay, take this here, put it equal to 0 and solve. And we learned 3 ways to solve for that. First way is the method of factors. The second way is the quadratic formula. The third way is the completing of the square. So once we could solve this equal to 0, then the answers we get for x would be the x-intercepts. What is the x-intercepts? That is where the curve cuts the x-axis. So those are 3 things you revise already for the night here. The fourth thing, if we express this format, y equal to ax squared plus bx plus c, that's a particular format which is called the quadratic format, as a completed square. That is, if we take this and we put it into this form here, right? Y is equal to a into x plus h squared plus k. A is this a here. H could be found by doing this calculation, b over 2a. And k could be found by doing this calculation, a 4ac minus b squared all over 4a. if we calculate HK and put it into this format, then this is known as the completed square format. And we could get the maximum or minimum value of y from this format. How do we get the maximum or minimum value of y? Well, we know that the maximum or minimum value of y occur when x plus h equal to 0. That's this part here is equal to 0. Then you could get the maximum or minimum value of the function. That is to say, we could locate this point here or this point here, the maximum or the minimum. How can we do it? Well, we could express this form in this particular form, which is the completed square. And when we put this part here equal to 0, we could calculate the maximum value of y or the minimum value of y. And we're going to actually do that in the example. So that is 0.4. So sometimes this one is a little tricky. In fact, it's the most involved. But for now, let's just take it as it stands. Okay. So let's come down to the next part. We could also get the values of x at these maximum and minimum points by noting the same thing. X plus h is going to be equal to 0. So once we are able to get the minimum or maximum value of the function by noting that x plus h equal to 0, putting that here and solving, and also we could get the value of x at which this maximum or minimum is occurring by using the same fact, right? We could actually locate the minimum or the maximum point, all right? And in your textbook, they tell you that the maximum or minimum point is given by these values here. This h comes from this calculation, and this k comes from this calculation. But we could get it by utilizing this fact here and this fact here, and I will be showing you that in a moment. Okay, so for example, in the May-June 2005 paper, that was paper 2, but of course, remember, you could get in paper 3, or part of it you could get as a question in your multiple choice. Nothing is impossible. Also remember, you guys, that in multiple choice, you cannot use a calculator, right? But in paper 3, you can use a calculator, okay? Remember that. So in May-June 2005, number 9A, we were asked to write 5x squared plus 2x minus 7 in the form a into x plus h squared plus k, right? They were asked to put it into this form, which is really called the completed square form, okay? To do this, right, we had to know what h was, and h is b over 2a. So let's work out that before we continue. Let's work out h. B from here is 2. So I'm going to put the 2 on top, right? Over, which is this over, 2 times a. 2 is here. What's the value of a? Well, a, if we go here, is 5, right? Remember, it's ax squared plus bx plus c. So that's how I could put a as 5 right there. So I'm going to put in the 5. So what will happen is that this 2 will cancel into itself one time and into here one time. So you end up with 1 over 5. Let me do it for you here. 2 into 2, 1, 2 into 2, 1. So 1 will go on top, right? And 5 will remain below because 5 times 1 is 5. So you end up with h being equal to a fifth. And that's what I wrote down here, right? So h is equal to 1/5. So that's the first step in finding the form because you have to get what h is. The next step is to get what k is. So how do we know what k is? Well, there's a formula for k that you have to memorize. So you have to memorize this formula. You have to memorize this formula. This one is easy, b over 2a. And I've done experiments in a class within 2 minutes. Even the slow students in 2 minutes could memorize this. It's just a matter of putting a little effort, okay? So k is 4ac minus b squared over 4a. Where do we get a, c, and b from? Well, it's right here. A is 5, b is 2, and c is negative 7. So let's work it out. Let's take our time and work it out. So 4 is this 4. A from up here was 5, so I'm going to write in a as 5. C, where do we get c from? C is this number here, minus 7. So I'm going to write in minus 7. Then b, where's b? B is 2. So I'm going to put it 2 in here. And then, of course, squared, as this squared, all over here. 4, A. What's A again? A is 5. So I'm going to put 5 in there. Okay. So when I work out 4 by 5, 20 by minus 7, that is minus 140, minus 2 squared. 2 squared is 4. So this will be minus 140 minus 4. That gives me minus 144 on top. And then 4 times 5 below will give me 20. So this is what K is working out to be. And then if I put this on my calculator and divide it out, or divide it manually, I'll get negative 7 and 1/5. So we now have the value of K as negative 7 and 1/5. Good? So we know how to get H and we know how to get K. Now remember, the form that they required us to put it in was A into X plus H squared plus K. So we're going to put it in now. A is 5. So that means I have to put A here as 5. Let me write that in. X is still X. H, let's see what H is. H is equal to 1/5. So where I'm seeing plus H, now I have to put in 1/5. So I'm doing that. This square here is this squared, and then we have plus K. What is K? K right here, we worked out to mean minus 7 and 1/5. So we're going to use that here. Plus K is plus minus 7 and 1/5, which is the same thing as minus 7 and 1/5. So now we would have worked out what our required form is. This is the required form that we needed to put into. So this is an answer, right? So number 9A in May, June 2005, this is the form which is known as the completed square form that they wanted us to be able to do. Now in 9B of that same year, they said, hence determine the minimum value of the function. Hence mean using what you just did, take that and help you to do the next step, which is to find the minimum value of the function. Okay, now we need to recall how do we use what we just did, which is this, to find the minimum value of the function. Now, if you go back up to where we were discussing all the relevant points, I told you that if we express the quadratic, right, which is what we just did, as a completed square, which is in this form, we could get the maximum or minimum value of y by noting that these points occur when x plus h is equal to 0. In this case, we know it's a minimum point, and it will occur when x plus h equal to 0. In this particular equation, x plus h is x plus a fifth. So the minimum value of this function is going to occur when x plus a fifth is equal to 0. So that's what we're going to do. Y minimum occurs when x plus h equal to 0. That is to say, when if y is equal to 5 into x plus a fifth squared minus 7 and 1/5, which we just got up here, if y is equal to that, which I wrote back down here, then y minimum would occur when this part here, the x plus a fifth, is equal to 0. So we're going to put that equal to 0 in there and work out what y min is, the minimum value of y. So 0 squared is 0. 0 times 5 is 0. 0 minus 7 and 1/5 is minus 7 and 1/5. So the minimum value of y is negative 7 and 1/5. That occurs when this part here is 0. It's always going to give you the maximum or minimum when this part here is equal to 0. That was a point that you needed to learn coming into this exercise. It was point 4. And that is what is going to help us to do part B, 9B in 2005. That is to say, this part here is 0 and you work it out. So the minimum value was y min minus 7 and 1/5. The next part of 9B, which was 9B part 2 in 2005, was find the value of x at which this minimum occurs. Because remember, at any point, the minimum point will have an x coordinate and a y coordinate. So the minimum point, when you draw this graph, this minimum point, it will have an x coordinate and a y coordinate. So far, we found the y coordinate. That was, this y coordinate is minus 7 and 1/5. We haven't found this x value yet at which it is occurring. So that is what they're asking us to do here. That is what they're asking us to do in part 2. Find the value of x at which the minimum occurs, which is this value here. How do we do it? Well, we learned that in the same instructions above, that the value of x at which the minimum occurs is going to happen when x plus h is equal to 0. Same thing that we had utilized here. When this is equal to 0, we're going to utilize it to get the value of x at which the minimum is occurring. So the value of x at which the minimum occurs is when x plus h equal to 0. That is x plus a fifth equal to 0, because remember this part here, x plus h is this. So when x plus a fifth equal to 0 is when you're going to get that minimum occurring. So look at there. X plus h equal to 0, which means x plus a fifth equal to 0. So let's find out what's the value of x that will cause this to happen. Well, some people say bring this over on the other side and change the sign. So plus a fifth becomes minus 1/5, right? Or some people say do the opposite. So if this is plus 1/5, you minus 1/5 on the left and you minus it on the right. At the end of the day, the value of x that makes this true is when x is equal to negative 1/5. So this is going to give us the value of x at which the minimum occurs is x equal to negative 1/5, right? So if I go up here and this was my minimum point, the value of x that has to go here will be negative 1/5. Good. So the coordinates of this minimum point on the curve is going to be y negative 7.1/5, and the x value here is going to be negative 1/5. Okay. So that's important. In 9C of that same question, they ask us to find the values of x for which 5x squared plus 2x minus 7 equal to 0. Now we know 3 ways to solve this, right? Method of factors, the quadratic formula, and completing the square. But seeing that we did all of this work here, right? We did all of this work. We're going to utilize that, and that's normally a hint. If you do all of this work in completing the square, then it means then that you should really, take advantage of that fact. So we already know that 5x squared plus 2x minus 7 could be written as 5 into x plus a fifth squared minus 7 and 1/5. How do we know this? Because we already expressed this in this form, right? We did that. That's what we did right at the top here, right? Look at here. So we're going to use this to help us. So if we have to solve this, it is the same as solving this, right? So let's start to solve what we have already. So the first step we did was to deal with this minus 7 and 1/5 by bringing it over on the other side and changing the sign from negative to positive. Or some people say add it on both sides. The next step is to get rid of this 5. So I'm going to divide the left-hand side by 5, right? And if I divide the left-hand side by 5, I'm going to end up with the 5 disappearing because I'm dividing by 5 on both sides. So I'm going to end up with x plus a fifth squared is equal to 7 and 1/5. I'm going to divide by 5. Remember, I divided the left-hand side by 5, so it came out, and I'm dividing the right-hand side by 5 now. So if I do that calculation, right, you guys, if you have a calculator, you could check it. But if we divide it, we're going to come up with 1 and 11 over 25, right? This works out to be 1 and 11 over 25. The next step is to get rid of the squared sign here. See this square? We have to get rid of it. And to get rid of square, we square root. We do the opposite. So I'm going to square root this side, and I'm going to square root this side. So I'm just going to write it here. Square root both sides, right? Will result in x plus a fifth. And if I square root 1 and 11 over 25, if I plug that in on my calculator, right, and I use fractions and so, I could get an answer. And the answer will be 1 and 1/5. But there's something very, very, very important here. And many people will get this wrong. Because your calculator is going to give you 1 and 1/5. But in this particular case, you have to know that the square root of a number is plus or minus. Calculator is not going to give you that answer. So that's very important. And therefore, we could solve what x is by saying this plus 1/5 here, we bring it over on the other side and change the sign, or some people, that's what some people would say, or the real thing is you minus 1/5 and you minus 1/5. At the end of the day though, you'll get x by itself on the left, and on this side you'll have the minus 1/5 plus or minus 1 and 1/5. Okay, so your answer is either going to be x equal to negative 1/5. If we use the plus here, it'll be plus 1 and 1/5. Or the other value for x will be negative 1/5. And now we're going to use the minus option, minus 1 and 1/5. Okay, so there are two possibilities. X, therefore, is going to be, if I work out minus 1/5 plus 1 and 1/5, I'm going to get an answer there of 1. Or if I work out this one, minus 1/5 minus 1 and 1/5, I'm going to get an answer of negative 1 and 2/5. Okay, so now I have two answers, two values for x, this one and this one. So we would have been able to find the values of x for which 5x squared plus 2x minus 7 equal to 0. One value of x will be x equal to 1, and the other value of x will be x equal to minus 1 and 2/5. Right? So that would have answered part C. In 9 part D of May-June 2005 paper, right, they said to us, which was the crux of the whole problem, right, sketch the graph. How are we going to sketch this graph of y equal to ax squared plus bx plus c? Or in this case, particular case, the graph of y equal to 5x squared plus 2x minus 7. So they want us to sketch this. But when we sketching it, they want us to show them the minimum point, the y-intercept, and the x-intercepts. Now, to the trained eye, you would have realized that all along in doing 9A, 9B, 9C, we would have gotten the answers for all of these things, and which would help us to sketch the graph. Okay, so let's go through and see what they're talking about. So the first thing is the minimum point. Well, we knew that it was a minimum point because the 5 here was positive, so we knew it's going to be a trough, right? So we know it's going to go like this. Then the minimum point, we had found it from 9B, part 1 and 2. We had got the minimum point to be negative 1/5, negative 7 and 1/5. I'll just go back here so you could see it. When I did it here, x was negative 1/5, right? And then the y value was negative 7 and 1/5. So we had actually got the minimum point already. So on our curve that we have to sketch for them, right down to the bottom here, right, that'll have to be negative 1/5, mean go negative 1/5 in the x direction, and then you're going to come down at this point right here, which will be negative 7 and 1/5. That'll be a y coordinate. So this here is going to be a minimum point as you would have obtained from 9B parts 1 and 2. So you already worked out that, so you could put that on your sketch. The y-intercept is also a point that they wanted us to show. They wanted to show this on the graph. But you guys might remember that the y-intercept is c, right? What c am I talking about? This c. Because if y in a quadratic equation is ax squared plus bx plus c, then in this particular graph or this particular quadratic, the c value, which is this, would be the y-intercept, which means the graph is going to cut the x-axis at the y-axis, sorry, at minus 7. That's the y-intercept. So if you notice, this graph is going to come here and come back and cut the y-axis at this point here, which is minus 7. Minus 1, 2, 3, 4, 5, 6, 7, minus 7. So it's cutting here. Okay. So in this sketch, we showed the minimum point, which is here. And we have the coordinates for it. We showed the y-intercept, which is right here, where it's cutting the y-axis. And then the x-intercepts. If you recall, to find the x-intercepts, that was done in 9C. Let's go back to 9C and see what we did. In 9C, we took this equation, recognized that it was in this format, and we put this equal to 0, and we solved it. And we got two values of x, noting that these two values of x would be the x-intercepts. One is x equal to 1, and one is x equal to minus 1 and 2/5. So let's go here. Let's look for x equal to 1. This is the x-axis. X is equal to 1. So that's going to be an x-intercept, which is where the curve is going to cut the x-axis. So it cut it right here. Then if you come back on the other side where it's cutting the x-axis again, will be here, which will be the other value that we had gotten, which is x equal to minus 1 and 2/5. That's going to be this point here, minus 1 and 2/5. So it's going to cut here. So this sketch that we have here is the sketch that they wanted, which is showing everything. It's showing a minimum point. It gives you the values of the x and the y coordinates of the minimum point. It shows you the x-intercepts, which is where it cuts the x-axis. Something is happening here, weird. I don't know what it is. All right, so that's basically it. I'm seeing some strange things coming up on my screen. I don't know what it is about. Is anybody doing anything there? I'm seeing a lot of stuff coming in here.
Not me, sir.
Yeah, I don't know what's this about here that you all are seeing on the screen now.
I guess somebody hacked the class, sir.
Well, I hope not. Right, well, it came off, whoever was interfering, because I didn't allow sharing, but I see that happen. So, right. So let's go on to the next part, which would carry us to session 5, because that would basically be the end of this session here, where we would have drawn out the sketch and answered all the different parts to it. Okay, so let's go on to session 5. Okay, so my session 5, right? So in session 5, I wanted to go to the PowerPoint, right? Because that is where we'll be able to talk about volumes and surface areas, okay? So let's see how that went. Right, so session 5 speaks about volumes and surface areas of simple right solids, all right? And we are looking at, firstly, prisms and pyramids, right? But the prism is the first one we look at. And a prism is a uniform solid that has the same shape or cross-section along its length. And we would meet many prisms, right? One here is a cube. This is a cuboid. This is a triangular prism. This is a cylinder, right? So those are some examples of prisms. And what makes them prisms is that there's a uniform cross-section along its length. So if we look at this shape here, this shaded area would be uniform along this length here. So if we were to cut it with a knife, for example, and look in this direction, let me get 10. If you look in this direction, you would always see, right? You would always see that that face all the way through. So we call it a uniform cross section, as opposed to if you had this particular shape and you cut along this direction all the way through, right? What you would be seeing is a different size circle all the way through. So at first you would see this circle, but when you reach down to, let's say right here, you're going to be seeing a very small circle. So what we say is that this one here does not have a uniform cross section, whereas this has a uniform cross section. And all the other examples that we'll go through have uniform cross sections. So those with the uniform cross sections are known as prisms, right? This one here, this cone, is actually a prism, pyramid, all right? But right now we are focused on the prisms, right? Now, we need to know how to do two things with prisms. We need to know how to get the volumes, and we need to know how to get the cross-sectional, not the cross-sectional, but the total outer areas, okay? So the main equation is this one here, which tells us how to find the volume of a prism. Now this A, the A here is the cross-sectional area, that is a regular cross-section throughout its length, and this L here is the length perpendicular to that cross-section, okay? So this formula, A times L, is very important that you remember to use it when called upon, all right? Sorry about that. I'm trying to change the screen. Let me see if I go here. Right. So let's go to this particular one. Let's say we wanted to find the volume of a cube. Well, remember the volume equation is always the area of the cross-section A times the length perpendicular to it. So in this case, the area of the cross-section will be the area of the square that is shaded. And the area of a square is side by side. The length that is perpendicular, which will be this length here, right, has a length of S. So in the formula, right, this length here will be S. So that's how we got S here. So if I need to get the volume, I'll simply say S by S by S, which is going to be S cube. So you could learn S cube, or you could just simply remember that the volume of any prism is A cross-sectional area times L, the length perpendicular to it. But you need to know how to get the cross-sectional area of different things. So a square is easy, it's side by side, right? In the case of the next one, which is the cuboid, right, you would need to recognize that if we have to get the volume, again, it would be A times L, right? Where A represents the area of the shaded surface, which in this case is that surface, right? And the length perpendicular to that surface would be L. So we'd multiply the area shaded, which is B times D. The area of that rectangle is the length times the breadth, or B times D. And then when you get the area A of the shaded surface, which is this calculation here, we simply multiply it by L, which is the length perpendicular to it. So the volume of the cuboid is BDL, right? So it's a very simple thing, nothing too difficult. Just remember it's cross-sectional area times length perpendicular, and we could calculate. Another example of a prism that you might bounce up is a triangular prism, where the volume will be the area A of the regular cross-section times L. Remember, that's a constant for volumes of a prism, always area of cross-section times L. So the volume in this case would be the area of the triangle A times L. L will be the perpendicular length. But do you know how to find the area of a triangle? And when I ask that question, most people say, yeah, so the area of a triangle is equal to base by height over 2. They forget to say it's base by perpendicular height, right? But they say base by height over 2. Or some people say a half, open brackets, base by height, a half base by perpendicular height. Now remember, this is only one way to find the area of a triangle. There are two other formulas, and you guys are supposed to know those formulas, right? So if you don't know it, go back and review it, and then you may have to use it to find this area here, depending on the information they give you. Hopefully, they'll give you a nice, easy one where you just use this formula and everything is nice, but sometimes that's not what happens, okay? So that's how you'll find the area of this the volume, sorry, of this particular prism. Now this one here is a very common one. They love to bring this for you, either the whole cylinder or half of it, right? They love to bring this for you. And a cylinder is simply a prism where the regular cross section is a circle. So in this case, the regular cross section is either, you could view it as this circle here, or if it's lying down like this, it will be the circle. That's the regular cross section. And the length perpendicular to it is L, whichever way they put it. So how would you find the volume of a cylinder? Well, seeing that it's a prism, it'll be A times L, where A would be the area of the regular cross-section, which in this case is the area of the circle, times the length perpendicular to it. So you need to know what's the area of a circle, and the area of a circle is pi r squared. And then when you get that, you multiply it by L, okay? You also need to be aware that the curved surface area of a cylinder is found by taking 2 pi r and multiplying it by L. That's the curved surface area. So that's something you need to memorize as well. All right? Yeah, so you need to memorize that. And here, in this diagram here, we were just showing you how we came up with that curved surface area being 2 pi r L. That's this here, right? And the reason for that is that if you take this cylinder and you cut it along where I'm showing you the red lines here, and you open it out, the circumference of the circle at the top, right? That circumference, if you cut it and you open it up, it becomes this top part of a rectangle when you open it out. And the circumference of a circle here is 2 pi r. So when you open it out, the top of the rectangle from A to B becomes 2 pi r. And of course, the L remains. So if I wanted to get the curved surface area of this cylinder, it would be the same flat area if I cut and open it. And that flat area is the area of that particular rectangle, which would be its length by its width. And the length on top is 2 pi r, and the width would be L. So that's how they get the curved surface area of any cylinder as 2 pi r L. Also, in your exams, they may give you a question where you need to combine that curved surface area with the area at the bottom, if it's just closed off at the bottom, and add them together. Or if they wanted to get the total surface area where you had to include the top and the bottom, then you'd have to add 2 pi r squared. Because remember, one of the circles is pi r squared. So if you had to get two of them, it will be 2 pi r squared. That's why you're seeing 2. So in this particular case here that I showed you, the total surface area would be made up of the curved surface area plus not the area of one end, but both circular ends. That's why we had to use a factor of 2, right, to get 2 pi r squared. So again, I'm running through all the different possibilities. So let's look at an actual example. If you wanted to get the volume of this shape here, right, which is what they were asking you. Was it volume? No, in this one, they started off saying they wanted the surface area. So to get the surface area of this particular prism, what you would have to do is add up the areas of all of them. Yeah, you'd have to add up the area of all of them, right? So to get the area of all of them, you would add up the area firstly of, let's look here, of EDC. Where's EDC? EDC would be EDC. So it'll be this triangle here, right? So how do you get the area of this triangle? Well, they made it easy for you because they gave you the base, ED, 21, and they gave you the perpendicular height, which is 12. So that made it very easy for you. So you could get the area a half 21 by 12, right? But the good thing about it is that you have those triangles on both sides. So you have one on the right and you have one on the left that I'm showing you here now. So you have these two triangles. So that's why you see up here we multiply by 2, because there are 2 of them. Remember, you have to get the total surface area. So that would cover this. Then you're going to add the area of ABCE. Where's ABCE? That's A, B, C, E. So that would be the rectangle that I'm highlighting here now, right? How do you find the area of that rectangle? It's length times width. So the length is 76.5 and the width would be 20. So you multiply 76.5 by 20 or 20 by 76.5, which is this calculation here, and that will give you the area. Now, some people might think, well, The area of this sloping side will be the same thing as the area of the next sloping side, but that's not actually true, right? The area on the next side will be length times width as well. So that if we have to find the area of BCDF, right? What is BCDF? B, C, look where D is, and look where F is. So that'll be the sloping side on the other downside.
13.
Yeah, so that'll be 13 by 76.5, right? So that'll give you that area. And then the last area will be the base. And that base will be AEDF. So that'll be A here, E, D, and then F. So that'll be the base. And of course, that'll be length 76.5 by width 21. Okay, so you have 76.5 by 21. And of course, if you add up all of that, you'll get a total area of 4,383 centimeter squared. What I want you to focus on now is the unit. The unit of area is the length unit squared. So all the length units here was centimeters, right? Centimeters. So the area would be centimeter squared. If you were calculating volume, it would be centimeter cube. So that was actually the second part of the question where they asked you to find the volume in cm cube of the wedge. So how do you find the volume? Well, again, you always remember volume is A times L, which is the area of the regular cross section times the length perpendicular to it. Now, the area of the regular cross section will be this area here that I'm highlighting. And we already got that area. It was a half by 21 by 12. So that's this, a half by 21 by 12. That'll be the area of the triangle, and that will be the regular cross section. And then we have to multiply that by the length perpendicular to it, which will be the 76.5 centimeters. Okay, so once you do that calculation, you get 9639. And notice that the unit is centimeter cube. Centimeter cube is the unit. Okay, so that tells you how to do that part. Now there are some other parts which will be densities and so on. We would not go into that at this stage. Let's look at another type of question that they love to bring. They really love to bring these curved types of questions, right? So you need to be very familiar with them. All right, so let's have a look at that. This was a question brought when they brought in 2002. It was actually number 4B, where they give you this particular shape, right? And they wanted you to do some calculations with respect to that, right? The first question, the first part of the question said taking pi, because pi could be different quantities. So you always look out to see what they tell you pi as. Pi in this case had to be 22/7. They wanted you to show that the area of this shape was 459 cm squared, A, B, C, D, E, F. So if you look here, A, B, C, D, E, F would be A, B, C, D, E, F. So it basically means go all around, find the area. So what we did is we found the area of each various component. So the first thing is we're going to find the area of FGA. Where's FGA? FGA will be the left sector that I'm highlighting here in red, right? That will be what we find in first. And we notice that that area and this area here on the next side, which would be the area of CHB, right, would be exactly the same, right? So if it is that we can find the area of one, we could just multiply it by 2 and we get the area of the two of them. So the area of sector FGA, right, there's a formula. What is the formula? The formula for the area of any sector is pi r squared by theta over 360. Okay, so you should do some research on that. And theta will be the angle of the sector. In this case, the angle of this sector is 90 degrees, right? I'm highlighting it here, right? That angle there is 90 degrees, and the same thing on the other side. In other words, it's quarter of a circle. So if you put that into our formula, right, for the area of a sector, pi r squared by theta over 360, that'll be this formula here. Then pi is 22/7, right? R is the radius. If you look down in the corner, you'll see the radius as 7 centimeters. So that R squared will be 7 centimeters squared. Theta is 90, which we have at the top, over 360, right? And when you work all of that out, you're going to get 77 centimeters squared as the area of the sector. So we could write that in 77. And the other one on the right side, which is CHB, is also going to be 77 because they are the same sectors, quarter of a circle of radius, 7 centimeters. Now, the next part we are going to calculate in order to get the total area A, B, C, D, E, F. We're going to look at the area of the rectangle GHBA. So where's GHBA? GHBA is going to be, I'm highlighting it here now, GHB going back to A. Right? So GHBA is going to be the rectangle right down in the center at the bottom. And the area of a rectangle is length by breadth or length by width. In this case, it will be AB 16 centimeters by GA 7 centimeters. 16 by 7 is going to give us 112. Look at the unit, centimeters squared. So this area is going to be 112. So finally, the last area to make up the whole shape, right? A, B, C, D, E, F will be the area of the big rectangle at the top. That'll be the area of E, F, C, D. So that'll be E, right, F, C, D. How do we get that area? We say length times width. The length is 30 at the top, and the width in this case, or the height in this case, is 9. So it'll simply be 30 by 9, or 270 centimeters squared. So the total area will be the 77 for the two sectors, 112 for the middle rectangle, and 270, right, for that big rectangle at the top. And if you add all of that, you're going to get 459 cm squared. So we were actually able to prove this part here, right? Taking pi to be 22/7, show that the area of ABCDF is 459 cm squared. So we were able to do that. And once you prove like that, they usually put in these two are like that, which means we have proven something that they asked us in particular. The next thing they asked us to do is to find the volume, right? But it's a particular volume. Let's see what volume they wanted. Let's read here. They say water is poured into the container until the water level is 4 centimeters from the top. So if you look in the diagram, you would notice that 4 centimeters is the allowance given to the top of the water level. So where you see this dashed line here that I'm going across from J to I, that'll be the water level. If the container is 40 centimeters long, now what do they mean by it's 40 centimeters long? Let me see if I could give a little drawing to show you what they mean by that. So I'm going to extend here a little bit. I'm going to extend here a little bit. And I'm going to extend here a little bit. So what they mean is that, right, this container is like that. And it's filled up to a 4 centimeter, right, with liquid. So this is filled, right, with liquid like that. But the length is 40 centimeters long. So that means that this here on top is 40 centimeters long, right? So what we would have to do in order to solve this is to recognize that the volume, right, the volume that they are looking for, right, is always going to be for a prism, because this is a prism since it has a regular cross-sectional area, is always going to be A times L. We learned that at the very beginning of this topic, where A refers to the cross-sectional area. Now, the cross-sectional area that we're going to be talking about here will be J, I, C, B, A, F. right? That's the cross-sectional area that we're talking about, which is what I'm highlighting here. Okay, and then all you have to do that is multiplied by L, and L in this case is going to be the 40 centimeters. So we know this perpendicular distance is 40 centimeters. All we have to do is work out the cross-sectional area. Now, to work out that cross-sectional area, what we know is that one of the sectors is 77, so both are 77. The middle rectangle is 112, but we still have this top rectangle to work out, which is GICF, which is this. So we could add that in to get the entire cross-sectional area of this face here. Now, to get GICF, all we have to do is multiply the length of that rectangle, which is GI, times the width of it, or the breadth, which is IC. GI times IC. GI is from here to there, which is 30 centimeters. So we put that 30 in, and we multiply it by IC. Now, how did I get IC as 5? Well, remember, it was 4 centimeters from the top, and the whole height initially was 9 centimeters. So if we look here, it was 9. So if the water level is 4 centimeters from the top, then it means that the height of that rectangle is 5 centimeters, because 4 from 9 is 5. So that means that this figure here, IC, is going to be 5 centimeters. So when we multiply the length 30 centimeters by the height, which is 5 centimeters, we're going to get 150 centimeters squared as the area of that top rectangle. So I'm writing it in now, 150, right, cm squared. So now the cross-sectional area that we're interested in will be 150 plus 77 plus 112 plus another 77, right? So that's 150 plus 77. It's supposed to be 77. Well, 77 was the complete thing. Yes, that was an error on my part. I'm keep writing 77. It was 177. Let's see. Right. So I was putting 77 for each of them, but it was really 77 for the two of them. Okay. So it meant that each is not 77. It meant that both of them added up to be 77. Right. That's why it's in 177 in the total adding when you're adding it up 1. Okay. So really, I was putting 77 for each one. So I'm fixing it. It's supposed to be both of them equating to 77. So even in the final calculation here, it will be, right? It will be both of these here adding up to 77. I'm trying to get it, but 77, right? So it meant that you have 177 representing the two sectors. You have 112 representing the middle rectangle, and you have 150 for the rectangle on top. And that will give you the area of the cross section. Then you have to multiply that now by the perpendicular distance of 40, and that will give us the volume that they wanted. Okay, so your cross-sectional area of 339 times 40 gives you a volume of 13560. Look at the unit, cm cube. Notice that when you go to volume, it's cm cube. Now, if we go back and we read the question, right, it said that water is poured into the container until the water level is 4 centimeters from the top. If the container is 40 centimeters long and has uniform cross-section, calculate to the nearest liter the volume of water in the container. So this volume is the volume in the container, but if you notice, it's not in liters. They wanted their answer in liters. So we have to know the conversion, right? And the conversion is 1 liter is 1000 cm cube. So therefore, this figure here, 13,560 cm cube, in liters, we'd have to divide it by 1,000. And that brings it to 13.56 liters. So again, you might be tempted to walk off and think that you have the correct answer. But if we go back and read it again, they said calculate to the nearest liter. This is the exact answer, right? And we need to bring it to the nearest liter. So if we round this off to the nearest liter, which would be at this point, it will become 14 liters to the nearest liter. So only at that point, we would have actually answered the question that they were interested in finding out. All right, the next question, right, we want to just finish off our areas and volume. So I'm going to go to pyramids and then we'll close off there, all right, for the night. So let's look at another question that came up in June 2001, which was question 7, where here pi was a different value. It wasn't 22/7, it's 3.142 now. So always notice and remember, you have to see what they are giving you for pi. And they were kind to us. They told us what the curved surface area of a cylinder was, all right? And they said the diagram, not drawn to scale, represents an open metal container. And the cross section of the container is a semicircle with diameter, that's D, equal to 1.5 meters. The length of the container is 3.5 meters. Write down the radius of the cross section. Well, you need to remember that diameter is 2 times the radius. So therefore, the diameter over 2 would give us the radius. In this case, they told us the diameter was 1.5 meters. So to get the radius R, we'd have to take the diameter 1.5 and divide it by 2. And that will give us 0.75 meters. So it means that our radius is 0.75 meters. Then they wanted us to calculate in meters squared to 2 decimal places the area of the cross section, which would be the area of a semicircle. All right, so let's see how we did that. We got this already. The area of the cross section will be the area of a semicircle. Now, what is the area of a circle? It's area of a circle. Area of a circle is pi r squared. So the area of a semicircle will be pi r squared over 2, right? Or half pi r squared, any one you want. So let's put pi r squared over 2 or half pi r squared like we wrote here. So let's calculate it. A half pi is 3.142. Remember to use what they gave you. Don't use anything else. And the radius we got up here as 0.75. So we're going to use that for r. And remember, is r squared. So we're going to square it. So when you do that calculation, you're going to get this answer. And remember, the unit of area is going to be the length unit, m squared. So notice the area here is in meter squared. All right. But remember also that they wanted it to 2 decimal places. So always give it to the accuracy that they want. And 2 decimal places mean it will be 0.88 meter squared, correct to 2 decimal places. Having done that, you can go to the next one, which is to find the outer curved surface area, right? The outer curved surface area. Now, if you look at this shape here, it's half of a cylinder cut along the length. So if we knew the curved surface area of a cylinder and we found half of it, then that will give us what we want. So we want to find a half, whatever that surface area for a cylinder of 0.75 is. And they gave us a formula before we started for the area of a cylinder. It was 2 pi r h. So for our particular shape, which is half of that, we'd have to multiply that answer by a half. So we're going to take the half, multiply it by this formula here. 2 pi is 3.142. R is 0.75 meters. And the height, in this case, the h value really is the length. This here is really what h is. It's the length that is perpendicular to the cross-sectional area. Remember, volume is always cross-sectional area A times the length perpendicular. In this case, the cross-sectional area A would be the, yes, so. Okay, I just lost it there a little bit. We still calculating outer curved surface area. I went to volume. So let's get back to the outer curved surface area. So the outer curved surface area will be a half times 2 by pi by r by h, right? Which is this 3.5. And therefore, you are going to get this value here. All right. Let me rub off the volume because we didn't reach there as yet. That'll be probably the next step. Right? And when you calculate this, they wanted, of course, to 2 decimal places. So that means we have to come to this point, 2 decimal places, which would be 8.25. And again, because it's outer curved surface area, we have to give them the area unit, which would be the length unit, meter squared. All right? So that will be that part of the question. The last part said, or part 3 in B said the total outer area. So whereas we just got the curved surface area, now to get the outer area, we have to add in the 2 semicircles, which will be this one and this one, okay? Now, we had gotten the area of 1 semicircle before. Where is it? Here it is. The area of the cross section would be the area of 1 semicircle, which is 0.88. But we have to get 2 of them now. So we have to take that 0.88 and multiply it by 2 to get for those 2 semicircles. So that worked out to be 1.76 meters squared. So now to answer part 3, which is the total outer area, we'd have to add the area of the 2 semicircles, which is the 1.76, to the area of the outer curved surface area, which we had gotten here to be 8.25. So we're going to add that here, 8.25. So 8.25 plus 1.76 gives us 10.01 meters squared. And again, we round into 2 decimal places as requested. Good. Then they said, calculate the capacity in meter cube of the container. How do you calculate capacity? Well, it's the same thing as volume. So again, it's A times L for a prism. A would be the cross-sectional area of this, which is 0.88. And L will be 3.5. So it'll be 0.88 by 3.5, which would give us 3.08. Look at the unit, meter cube. Don't forget that. The curved surface area, the volume is always in meter cube. Right? The last part of the question said that water is poured into the container at the rate of 30 liters per minute. Calculate the length of time in minutes it would take to just fill the container. So we have the capacity already of this container. It's 3.08 meter cube, right? But remember, they told us that water is being poured at the rate of 30 liters per minute. So we need to convert this capacity of 3.08 meter cube to liters. So what's the conversion? 1 meter cube is 1,000 liters. So 3.08 meter cube would be 3.08 times 1,000 liters, which works out to be 3,080 liters. Now, they're saying that every minute, right, 30 liters is poured into the container. How many minutes would it take to just fill it? Well, how many 30 liters are there in 3,080? Because every time you put 30 or fill 30 out of the 30, 80, 1 minute passes. So let's see how many minutes there are by dividing. And when you do that division, you'll get 102 and 2/3 minutes, or 102, if you round it off, 0.67 minutes, right? If you bring it to decimals. And that's how you would go about finding your volume, or your time to fill that volume, okay? The last thing we'll do for this evening would be to look at pyramids, because sometimes you might bounce up these pyramids here. And what is a pyramid, right? A pyramid, let me just quickly read it for you, is a solid with a polygon or shape at its base, and all other faces meet at one vertex called the apex. So in this particular shape or solid, you always have a base. So in this base, you had a rectangle. So that's the rectangle down there. In this one, you had a triangle, right? So this one is called a rectangular base pyramid because of the rectangular base. This one is a triangular base pyramid, but there's a particular word they use for that. It's called a tetrahedron. So if you bounce up a tetrahedron, don't worry, it just means that it has a triangular base. And if you draw a vertical line straight up from the base, it will come to a point called the apex. All right, now the volume of a pyramid is given by this formula. remember the volume of a prism, right, which is what we were studying before, was the cross-sectional area, regular cross-sectional area, times the length perpendicular. Now, we are doing pyramids. You have a new formula. It's a third times the area of the base times the perpendicular height of the apex above the base, and that perpendicular height is known as the altitude. So that's why we see the word altitude, okay? So very important. You need to know again how to find the area of a triangle. And I mentioned to you that there were three formulas. Here you have one formula for the area of a triangle. Here you have another one. And here you have a third one. You have to be familiar with all three. So if you didn't do that before, make sure and go and do that research, okay? And all you do is apply this formula by putting the area of the base here, the altitude here, multiply the answer by a third, and that will give you the volume of that particular pyramid. This one here is one that we are very accustomed to. It is known as a cone, and it is a pyramid that has a circle as the base, or the regular shape or polygon at the base, okay? And there's something very particular about this that you need to know, which is that the slant height is used in calculating the curved surface area. So if we wanted to get the curved surface area of this cone, we would use this formula, pi r L, where L is the slant height, which is this slant height here. And it's the only formula that we have bounced up where we need to use the slant height and not the perpendicular height. So this is very important, and you need to take a note of that. The volume is still a third times the area of the base times the altitude, right? In this case, the base is a circle, so the area is going to be pi r squared, right? So remember that, which is this area here. So let's look at, of course, there's a sphere. Volume is 4/3 pi r cubed, and the surface area is 4 pi r squared. I've never really seen any questions come on that, but it's, you could take note of that, right? And the last two questions here for tonight, they said calculate the area of the base of the volume of this pyramid, right? And then they wanted to get the volume. So let's calculate the area of the base, and then, and then the volume. So the area of this base is a very simple one. It's a right angle triangle, which will be this shaded portion here. And so we would use this formula at a half times base times perpendicular height. In this case, the base could either be the 25 or the 10.5, and then the height would be the other one. So we use the base here as 25.2 and the height as 10.5. So when you multiply that out, you're going to get this as your area of the base. To get the volume, all we do is use the formula, a third times the area of the base times the perpendicular height or the altitude, and we put those things into the equation. So that would represent the area, which is this, right? The third is here, and the altitude is given to us as 34.5. So that's what we use here. Calculating that, we get this answer, and then we round it off to 1 decimal place. They didn't tell us what to round it off, so if you wanted, you could have left it like this. But if you decide to round it off like me, you have to tell them what you're rounding it off to. Okay, so that one was fairly simple. Let's look at our last example, which is if we had to deal with a cone, right? And in this one, they say calculate the volume and the curved surface area. So volume, again, for a pyramid is this formula, right? A third. They didn't tell us what to use for pi, but we selected 3.142, so you can do that. If they didn't tell you, you could even choose 22/7. That would be up to you, all right? But always look to see if they give you a value to use, all right? Then you look for R. Your radius here is 7.5. Sometimes they give you the diameter and you have to divide by 2. So be careful for your R value, right? And then you square it. So remember, it's a third times the area of the base times the altitude. And the area of the base here was the area of the circle, pi r squared. So that's why we're using pi as 3.142, r as 7.5, and we're squaring it. And then finally, altitude was the 18. So you use 18 here. When you calculate that, you get this answer. And notice, of course, the unit of volume is cm cubed here. I chose to round it off to 1 decimal place, and I told them that you didn't have to. You could have left it as it was before. Only if they told you to round it off, then you will round it off as I did, right? You would have to, but if you choose to leave it as it is, no problem in this case. So the final thing is to find the curved surface area of the cone. And the curved surface area of a cone, as we learned earlier, let's just double check it. What is it? It's pi r L, where L is the slant height. So we have to recall that. So we are not going to fall into any trap. We're going to use pi 3.142, r 7.5. Here's our r value. And then L is the slant height. So don't go and use 18. It's not correct to use 18. We have to use the slant height here, which is the distance along the slant. And that is a very important thing, where we have to use that slant height. Okay? And so when we multiply it out, we're going to get this answer. And we choose here to round it off to 1 decimal place. If you wanted to, you could have left it as it was without any issue. Okay? So that is how you would do that particular one. In the next class, when we come back, we would be looking at circle geometry. But between now and then, I would be sending you some questions to do. Some would be based on what we did, and some would be multiple choice. So you would start to get some practice with multiple choice. All right, are there any questions that you guys have?
No,
Do you have any
sir.
questions? No? All right, so this has been recorded, and it will be up on the YouTube site. I will post the link as soon as it's ready. It takes a little while to render, but I will post it up there for you guys. Okay? So
Sir,
if there are no, yes,
Sir Jamie and Ian is in the chat. Could you say hi for me, please?
they're in the chat.
They're in class.
Oh,
Can you hear me?
okay. So you want me to tell them hi?
Yes, sir.
All right, no problem. I'll do that for you.
Okay, thank you.
Okay. All right. So bye everybody. You all have a good evening. I hope it was helpful to you. And we will continue to do our work until the exam comes around. Okay. You all remember we sent off an email letting you all know how to get in contact with the ministry. So use that if you need to find out anything. Okay. So God bless, and you all take care.
Okay, have a good night, sir. Bye, everybody.
Okay. Bye everybody.
Right, sir.
You all
Bye.
take
Bye,
care.
sir.
Okay. Bye-bye.
Bye.